Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson, which continues our unit on the properties of vectors in space. In the last lesson, we learned some of their key characteristics and also solved some basic problems involving the addition or subtraction of vectors. Today, we will be continuing our studies by learning how to multiply a vector by a scalar. Are you ready, students? Let us begin. First, let us be reminded of the definition of a scalar in the field of vector geometry. Do you remember the definition of a scalar, students? Please take a moment and write your definition down.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I am sure that you remember your previous lessons on this subject. A scalar is a real number used to multiply a vector and is used in the operation of scalar multiplication. Let us learn how to apply scalars now. Observe this vector called A. let us say that its coordinates are x, y, and z. If we then double the properties of vector A as seen here, then its resultant coordinates are 2x, 2y, and 2z. This exercise tells us that it is reasonable to accept the following. If vector A at coordinates x, y, z is any vector and k is any scalar, then k times vector A will have its coordinates at kx, ky, and kz. This describes a vector with initial point at the origin and its terminal point at kx, ky, and kz. It is time for another activity, students. I would like you to work through this concept for yourselves. Please prove that if we multiply the sum of any two vectors in space by any scalar, the product will be the sum of each of the vectors times the scalar. Please go ahead.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Were you able to work through this proof on your own? Let us look at the answer together. First, let us assume that vector A is located at coordinates x1, y1, and z1, and that vector B is located at coordinates x2, y2, and z2. If we multiply these coordinates by k, these are the results. We can also express our answer in this way. You see, students, this allows us to derive our scalar from the new coordinates. We can see that the result of our equation is k times x1, y1, and z1 plus k times x2, y2, and z2. Alternately, we could say that it is equal to k times A plus k times B. We have completed our proof and shown the principle of multiplying a vector by a scalar. Well done. There is also a procedure called a scalar product operation. This describes when we multiply one vector by another, which produces a scalar as its final product. This is also known as a dot product. The dot product is an algebraic operation that takes two coordinate vectors and returns a single number obtained by multiplying corresponding entries and then summing those products. This concept should be familiar from previous grades. In this image, vector v dot vector u equals the product of the magnitude of the two vectors multiplied by the cosine of the angle between the two vectors. The scalar product of two vectors in space is a simple extension of the same principle. In this image, D1 and D2 are vectors in space. Their product is the dot product of both vectors' magnitude multiplied by the cosine of the angle between the two vectors. Let us solve this equation for the cosine of the angle. You see, students, we find out that the cosine is equal to the dot product of the two vectors over the dot product of the two vectors' magnitudes. It is important to note that the scalar product of the unit vectors is 1. The scalar product of perpendicular vectors is 0. This is because the cosine of 0 degrees is equal to 1, and the cosine of 90 degrees is equal to 0. Let us see an example. Vector A extends from the origin to coordinates 2, 3, and -1. Vector B extends from the origin to coordinates -1, 0, and -2. Note that the angle between these two vectors is 90 degrees. What is the scalar product of these two vectors? This is our formula. When we substitute the appropriate values, we are left with the equation 2 times -1 plus 3 times 0 plus -1 times -2. The sum is 0. We must multiply that sum by the cosine of the angle between the two vectors. But since the angle is 90 degrees, the cosine is equal to 0, and we are left with the same result. It is time for another activity, students. Please find the scalar product of these two vectors. You may start now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. If you substituted your values correctly, your answer should look like this. Did you find the scalar product to be 1? If you did, well done. That is all for today's lesson, students. Today, we have learned about scalars as they relate to vectors in space. We have learned to multiply a vector by a scalar and how to calculate a scalar product. Good work! Until next time, thank you, teacher. Thank you, students.